right, here we're going to do some synthetic division to divide these polynomials together. This is going to make dividing polynomials a whole lot easier. And if you haven't watched the notes that it's attached, that's a good way to go to start out to understand this process. But I'm going to assume that you watched the notes, and I'm going to proceed with some examples. So in that L-shaped box, you bring down the coefficients that you see here. Outside of the box, you put right here what makes what you're dividing by equal 0. It says m plus 3. m plus 3. Negative 3 plus 3 is 0. So my multiplier is that negative 3 right there. All right, to get the synthetic division machine going, we drop down the first coefficient. Then we move over and multiply this bottom number by our multiplier. 1 times negative 3 is negative 3. Now we add vertically, we get negative 10. Then from here we multiply. Negative 10 times negative 3 is positive 30. And now we add vertically, which is positive 5. Multiply diagonally. Whoop, right there now. You don't have to put those arrows in, but I'm just kind of showing. 5 times negative 3 is negative 15. Add together, 18 plus negative 15 is 3. Multiply that together, you get negative 9. Then we take 3 times our multiplier of negative 3, you get negative 9. And now you add. And now we are done with the division machine, folks. We've done everything, but we need to answer the question. And so when you are done, this bottom number represents your remainder. So our remainder is 7. The next value represents always the constant, the number without an x in the polynomial. And then you just go up. Constants like x to the degree of 0 or power of 0, this would be x to the power of 1. And that, well, I'm going to keep on going. This negative 10 represents the number of x's that are squared. And this 1 represents x to the power of 3. There's 1x to the third in my answer. Now go back through and sharpen this up a little bit, folks. This 10 right here is negative, so let's make a big minus sign. The 5 after that is positive, so let's put a plus sign. The 3 after that is positive. And the 7 after that is positive, so we're going to write a plus sign. But then the remainder needs to get divided by what you were dividing by, which is m plus 3. So the final answer is when I take this polynomial in green and divide it by the polynomial in yellow, the quotient, or the answer to the division, is 1x to the third minus 10x squared plus 5x plus 3 plus a remainder of 7, or 7 over m plus 3. And if you multiply the yellow binomial times the blue polynomial, you would get what's up there in green. You could check it by multiplying. Let's try number 4. Number 4, we make the L. We drop down the coefficients. Coefficient of the first term is 1. Coefficient of the second term is negative 1. Then negative 62. Then negative 41. Then our multiplier, the number that goes out here, is whatever makes what we're dividing by equal 0. What plus 7 is 0? Negative 7. Negative 7 plus 7 is 0. So our multiplier is negative 7. Let's start the machine up. You drop down the first coefficient. No matter what the number is, you drop it down. Then you multiply that number by our multiplier. 1 times negative 7 is negative 7. You add vertically. That gives you negative 8. Multiply that negative 8 by our multiplier of negative 7. You get positive 56. Add. You get negative 6 when you add. Multiply that negative 6 by your multiplier, you get positive 42. That makes a remainder of 1, folks. We are done with our machine. So this is our remainder. It's a positive 1, and we'll actually write it 1 over x plus 7. This is our constant. This is our x to the 1. This is our x to our 2. If there was more numbers to the left, it'd be x to the 3, x to the 4, x to the 5. Let's put those x's in. So this is 1x squared. It's a negative 8, so minus 8 x minus 6 plus 1 over x plus 7. You just sharpen up those signs, folks. If it's positive, you put a plus sign in between the terms. If the next term is a negative, you make a nice big minus sign. Beautiful. All right, let's look at number 11. Number 11 is only tricky for one reason. Let me rewrite this polynomial. X to the 5th plus 5x to the 4th. Where is the x to the 3rd? There are 0x to the 3rds. How many x squareds? 0x squareds. How many x's? 8 x's. Constant is 40. If you're ever missing a term, you have to replace that term with a 0. We are missing x squareds and x to the 3rds, so the coefficient of those terms are zeros, and I need to put those in standard form or descending order. So now that I acknowledge those zeros, I can proceed. My coefficients are 1, 5, 0, 0. Those zeros are so important. 8 and 40. This beautiful machine we call synthetic division only works if we acknowledge zeros and place values. What makes what we're dividing by? 0, negative 5. Negative 5 is my multiplier because negative 5 plus 5 is 0. Let's run the machine. Drop down the 1. Multiply the 1 by your multiplier, you get negative 5. Add them up, you get 0. 0 times negative 5 is 0. 0 plus 0 is 0. Take this 0 and multiply it by your negative 5. 0 times negative 5 is 0. Add your zeros together. You're like, Mr. P, I just keep getting zeros. Hang in there. 0 times negative 5 is 0. But now we add 8 plus 0 is 8. 8 times negative 40, 8 times negative 5 is negative 40. So our last value is 0. Remember that last value represents your remainder. That's nice, so our remainder is 0. This divided into that polynomial evenly. Here is our, I'm just going to put a big C for constant. Here's our x to the 1, x to the 2, x to the 3, x to the 4. So I have 1 x to the 4th, and then, there's 0x to the 3, 0x to the 2nd, 0x to the 1, and a positive 8. So let's rewrite this really pretty. We just have an x to the 4th plus 8. That's it. No remainder, no x to the 3rd, x squared, or x to the 1 terms. There we are, bada bing, bada boom. But the key there was making sure that you acknowledge missing terms and put a 0 in place of them. Let's try number 24. Number 24, I've got n to the 5th minus 7n to the 4th plus 10n to the 3rd. How many n's to the 2nd? 0. 0n to the 2nds, or n squareds. 0 n to the 1s, or just n's. And I have a negative 5. So my coefficients are 1, negative 7, 10, 0, 0, and negative 5. My multiplier is going to be whatever makes this equal 0. 5 makes that equal 0. 5 minus 5 is 0. Let's run the machine. Drop down the 1. Multiply that by 5. Add. Multiply that by 5. You get negative 10. 10 plus negative 10 is 0. Ooh, notice how I'm kind of shifting over. I'm not keeping these things aligned very well. That's naughty. Whoop. Whoop. 0 times 0 is 0. Ugh. 0 plus 0 is 0. 0. Oh my gosh. I said 0 times 0, folks. 0 right here. That was a goof up. 0 times 5. 0 times 5 is still 0. But, yeah. Now I'm here. I take this 0 and I multiply it by 5. I still get 0. 0 plus 0 is 0. 0 times 5 is 0. Ugh. So I'm going to get a remainder of negative 5. Remainder of negative 5. So Start on the right side, folks. This is your remainder. I'm going to put an R there for a remainder. Here is your constant. Here is your x to the 1, x to the 2, x to the 3, x to the 4. So we get x to the 4th, really like 1x to the 4th, but because it's a multiplier of 1, you don't have to write it down, minus 2x to the 3rd. You don't need to write down x squared, x to the 1, or the constant of 0, but you need to write down minus 5 as your remainder, and that remainder gets put over what we were dividing by, which is n minus 5. There we are. One other little skill that you need to be able to answer is, what is the remainder to the division problem? Well, really, notice this is dividing, just like we were doing, but we're using a fraction bar to represent division versus like the elementary division symbol that looks like this. And what they're asking you for is the remainder again, which we've been doing. It's been part of the problem. Like here, our remainder was negative 5. So you'd say, if they asked you in this problem with these numbers in this polynomial, what's the remainder? You'd say the remainder is negative 5. What's the remainder here? 0 was the remainder here. What's the remainder on these? 1 was the remainder. 7 was the remainder there. All right, let's give this part a shot. So, looking at the polynomial that we're dividing, we're not missing any terms. That's good. So jot down those coefficients in the machine: 1, 9, 22, 54, negative 18. The multiplier is what makes this, what we're dividing by, equal 0, which is negative 7. Let's proceed. Drop down the 1, multiply by negative 7. Add those together, you get 2. Multiply that by negative 7, you get negative 14. Add vertically, you get 8. 8 times negative 7 is negative 56. Add vertically, you get negative 2. Negative 2 times a multiplier of negative 7 is positive 14. Add vertically, you get negative 4. And I am done with the synthetic division machine. I'm done with that process. My remainder is negative 4. Remainder is negative 4. Hooray. This one looks fun because it's to the 5th power. Coefficients. Am I missing any terms first of all? Nope. Coefficients go in the machine: 1, 18, 90, 80, negative 13, negative 33. The multiplier is what makes that equal 0, which is negative 9. Drop down the 1. That's not always going to be a 1, folks. If it's a 10, if your first coefficient up here is 10, drop a 10 down. Then multiply that number by your multiplier. So you get negative 9. Add 18 and negative 9, that gives you 9. Multiply that by your multiplier, you get negative 81. Add vertically, you get 9. Multiply by negative 9, you get negative 81. When you add, you get negative 1. Multiply, you get 9. Add vertically, it gives you negative 4. Multiply, gives you 36. Ends with a positive 3. 3 is your remainder. All right.